index. So we're in 2.7, and we're going to look at some questions from our homework. We're going to look at the first one here. Adjust the focus a bit. Okay, so what we want to do is we want to use this index table to be able to estimate a price of a different year of the same goods. So you might want to say, okay, what happens to the price of a car? Okay, in 1 year to the next. You know, a car in the 1970s, that equivalent model is going to cost a lot more today. How do they determine that? They use this consumer price index. And this is just a collection of different areas of the economy. So it's kind of an average of all the different parts. Food prices, housing, entertainment prices. They all go together to give you this CPI, or consumer price index. So let's see what we have here. It says, use a consumer price index in the table below to find the amount that would be charged in 2001 for the same amount of groceries that cost $168.10 in 1995. Give your answer to the nearest dollar. Now, how we set up the ratio is not important as long as we are consistent. So when we look at this first question, we've got 2 years. So we've got 1995 and we've got 2001. Doesn't matter which one goes on the top as long as we are consistent. So I'm going to go ahead and put the index on the top and the price below. So let's see what we have here. And we'll do 1995 first. So these groceries in 1995 costed $168.10. And what's the index in 1995? Okay, if we look up that index value, it's 152.4, right? Is everyone okay with that? Now you can flip that over, and you can put the 168.10 on top and the 152.4 down below. Doesn't matter, as long as you are consistent. Okay, so index is going to be on the top. So what's the index value of 2001? The index value is 177.1. And do we know the price of those groceries in 2001? No, that's what we're trying to find. Okay, so now we can just cross multiply very quickly here. So we'll just cross multiply. And that's going to give us our equation, cross multiply and then divide. So that's going to give us a 152.4x. And that equals now those two multiplying together. So 168.1 times 177.1. That gives you this here, 29770.51. Okay, we'll divide by that 152.4. And that gives us then our x value to be price of those groceries. And it says round to the nearest dollar. So rounding to the nearest dollar, it looks like it's going to be $195. And we just rounded again to the nearest dollar. So that makes sense because we know the groceries should go up in value, right? As years go on, inflation adds up, so the value of your money is less and less. Some years are higher than others. Once in a while it goes down, but not very often. Most of the time, inflation goes up, especially like right now. Right now, the inflation is really high, right? It's going up, but there's been times where it actually deflates, but not very often. Okay, question 3. We need to set up a ratio for question 3. The ratio of the distances of a pitching wedge and an 8-iron will drive the ball is a 4-to-5 ratio. Okay, if a golfer averages 92 yards with a pitching wedge, how far should she average with an 8-iron? Now, how do we set up this ratio? Okay, it says a ratio, so that's a fraction, of the pitching wedge to the 8-iron. So pitching wedge is going to go on top. 8 iron is down below. So let's make sure we have this right here. So our ratio is going to be the wedge over the iron. Now, that ratio, it says, is what? Is 4 to 5. Okay? And that is the wedge to the iron. It's a 4 to 5 ratio. Now, it says the golfer averages 92 yards with the pitching wedge. So that means my 92 is going to go on top because that goes with the pitching wedge. And down below, we don't know the 8 iron, right? So that's unknown. Now we can cross multiply, and we can get our new value. So that gives you 4x equals now, when you multiply 92 times 5, that's 460. We'll divide by our 4, and now we know that x comes out to be 115, and that's yards. So is everyone okay with how I did that? Do we see how I set up the ratio? Because it told us which one was which, right? The and, that means that division part. So pitching wedge went on top, 8 iron went down below. It says it's a 4 to 5 ratio, so that's 4 over 5. So that's the wedge over the iron. And the hard part is just simply figuring out how I set up my ratio. And once it's set up, then you cross multiply, and it's very, very simple. Question 6. Okay, question 6 here. We're looking at the price of selling these school pennants. So students at East Central High earned $366 selling pennants. They want to make $3,070 for their club trip. What percent of the goal has been reached? And we want to round to the nearest 1/10 of a percent if necessary. So we need to find our percentage. So how do we find that percentage? Well, we need to take what we have earned divided by the total that we need. Percentages are also a ratio. So how much money have we earned so far? Okay, we've earned $366 out of a total of 3070. And we're going to go ahead and divide. And that's going to give us our decimal equivalent. We'll take that decimal and we'll turn it into the nearest 1/10 of a percent. So 366, divide that by 3070. And that comes out to be 0.119 if we round. And as a percent, that's going to be 11.9%. Yeah, that would be okay. In this case, though, I would be okay with that, but it says round to the nearest 10th. Okay, but yeah, if you did 12, I would still count it okay. But if you follow the directions exactly, they want it to the nearest 1/10 of a percent. So we actually need 3 places because percents take up 2. Okay, now question 7. We did one very, very similar to it at the beginning. So we'll talk about 7, but I think I'll leave 7 for you to do. Now, 7 is almost the same as question 1. What's the only difference? Just the years and the numbers. Right? So you set this up the same way. Index over the price. So you plug your index value in on the top, price down below for each of the 2 years. You set it up the exact same way that we set up question 1. Question 8. The 39% is what number of 68? Okay, so how would we set this up? Now, first thing we need to do whenever we work with percentages is we need to turn this into a decimal. So we got 39%. So as a decimal, that's going to be 0.39. Okay? And it says 39% of what number is 68? So, what do we know? 39% of what number is 68? When I find that number is going to be larger than 68, right? Because we want to be able to take 39% of whatever number we find and get our 68. So how would we set that up? Well, we have 0.39 as a decimal times some number x. We want that to be 68. So that's the way that we'll set it up. Because whatever number I find, right, it might be 100, it might be whatever it is, when I take 39% of that, what should I get? 68. My answer should be bigger than 68. So now we can go ahead and divide by that 0.39. What does that give me for my value of x here? We've got 68 divided by 0.39. And that doesn't say how far to round. We'll just round here. To the nearest tenth. So it's going to be 174, right? If we round 0.4. Now, how can I check that? If I take 174.4 and I multiply that by 39%, what should I come up with? 68, right? It's off a little bit because of the rounding. There's that number, okay? So 39% of this number should give you what? 68. Do you see how I set it up? Because it says 39% of what number is 68. So we found it, and we were able to check because we could take our number that we found, times it by our 39%, right? And we get out what we need, which was a 68. Okay, so that was question 8. 17. There are a lot of them like 17. They're all almost the same. We want to find the best buy and give the unit price. In most big box stores, this is already done for you. When you go shopping at one of the larger stores, they already give you the price per ounce or price per item, whatever it might be, usually in like a little yellow sticker. But 20 years ago or less, or if you go to a smaller store, they still don't do that. So if you go to some other store that's not Walmart, if you go to a smaller grocery store, they may not do this. You may have to do it yourself. So what we have is we've got two different brands of equivalent items, and they're different sizes. And we want to figure out, well, which one is going to be the better buy? And when I talk about the better buy, I want the unit price to be the lowest. So when we talk about the unit price, that's going to be the price, and it's always the same, over the size of the container. So it's always price over size. Set that ratio the same every time because it's cost per ounce, right? Cost per pound, cost per number of items. So it's always the cost divided by the size. So when we look at brand X, when we talk about brand X, okay, it's $2.88, and the size of that container is 12. So we're going to go ahead and just divide them out, and we're going to see the cost per ounce here. $2.88, divide that by 12. That gives you 24 cents. So that's per ounce. So there's that. What about brand Y? Well, for brand Y, it's smaller and it is cheaper, but it's $2.07. And instead of 12 ounces, it's only 9. Okay, so 2.07, we're going to divide that by 9. And that's going to give us now 23 cents per ounce. So which one's, in this case, going to be the better buy? In this case, the smaller container is actually the better buy, right? Maybe it's the store brand. Maybe the smaller store brand container is actually cheaper per ounce. Does everyone kind of see how that works? And there are several of them that are the same thing. The very important thing on these, though, is it's always price divided by the size, or number of units in that container. It might be number of candy bars in a box. Okay, you take the price of the box of candy bars, divide it by the number that are in there, and that would give you the price per candy bar. Or in this case, price per ounce. Or like on ground meat, divide it by the pounds, and that'll give you price per pound. But you always want the one that is the cheapest, and in this case, the smaller container is actually the better buy. Okay. Now, last time we had just begun working in 2.8. And 2.8, I think, is one of the more difficult sections. 2.9 is quite a bit easier. But 2.7, students struggle with, and you'll see these exact same questions again in intermediate and again in college algebra. So we need to make sure that we at least have seen them before, and hopefully for intermediate, we're able to solve them, but for college algebra, you should for sure be able to solve them. Now, on these, there's three types. There's distance problems, mixture problems, and investment. And they're all going to be done the same way. Distance is slightly different, but they're all pretty much the same family of problems. So they're going to be done the same way. We draw a diagram. We label all the pieces, and we multiply to get either the pure, or the distance, or the interest. And then we solve it, and we get what we need. Now, last time we had done a few of the mixture questions, where we mix the chemicals together. We're going to do another one of these, maybe two, and then move on to interest questions, and then we'll look at distance after that. So we have not done question 23. And this is on page 178. So we had done a couple of these last time, but we hadn't done question 23. Students struggle with these because there's lots of different parts, and we have to make sure that we know what goes where. So we're really going to take our time and focus on how to set this one up correctly. Minoxidil is a drug that has proven to be effective in treating male pattern baldness. Water must be added to 20 milliliters of a 4% minoxidil solution to dilute it to 2%. How many milliliters of this water are needed? And it says, hint, the water is that 0% minoxidil. So let's think about what we've got. We've got 3 containers. We've got 2 containers that we're going to pull off the shelf, and we're going to mix them together to get the third. So this container, number 3, is going to be what we end up with. Container number 1 is what we start with. And the second container, well, in this case, it's going to be the water. So a pharmacist might have to dilute the mixture down a bit, because not everybody needs the same concentration of this. Some may not be able to handle a higher concentration, so they have to dilute it down. So the pharmacist goes to the shelf, and he has 20 milliliters of a 4% solution. So we have an amount for each of these, and we have a percentage rate. So the pharmacist on the shelf has 20 milliliters of a 4% solution. So that is what we're going to start with. So we're looking at containers, and each of these containers has an amount and a percentage rate that goes along with it. So we start by going to the shelf on the pharmacy, and we have a container that has 20 milliliters of a 4% solution. Now that is too strong for the patient. So we're going to have to dilute this down with water. So we're going to add some water. And we want to dilute it down to 2%. So we want to end up with 2% over here. Right? So why is it 2% going in box 3? It's going in box 3 because that's where we have to end up. When I'm done and I give the bottle to the patient that has the droplet with the minoxidil in it, I want that to be 2%. So that's why it's going over here. Box number 3 is always what you end up with. So when we mix these together and I give this to the patient, that patient needs that 2%. So that's here. Now, to dilute it to get what we want, we're going to have to add some water. So do we know how much water we need to add, milliliter-wise? No. How much minoxidil is supposed to be in water? Is there any chemicals in water at all? No. So water should be 0% because it's pure. Pure water, nothing else. No minoxidil. 1 plus 2 is 3, so that's 20 plus X when we add across. Okay, let's make sure we understand where the pieces went and why. This is what I started with. On the shelf at the pharmacy, I've got a little container, and that container has 20 milliliters of a 4% solution. That is too strong for the patient, so I have to add some water to dilute it down. So water has no minoxidil in it, so that's why it's 0. Now, I'm going to fill that up with some water, so it's gaining the amount, and I want it to be 2%, so I diluted it down. Now we need to determine how much water to add. So we do that by looking at our pure. And the pure is the amount times the percentage rate. So amount times the rate is going to give you the pure. So on our first one, what do? These go together. Now, with these percentages, we need to turn them into a decimal. So we're going to look at our first one. These are going to get multiplied together. So 4%, well, that's 0.04. And how much is in there? 20. So those get multiplied together. Order doesn't matter because it's commutative. What about the next one? Multiplying those together. Well, it's 0 times X. And what about the third one on the other side? Well, the third one is 2%, so that's 0.02. And how much is in there? 20 plus X. Okay, so this is what we've got. Now, we should be able to find out X, and X is going to be how much water I have to add in. So let's go ahead and calculate this out. So we've got 4% of that 20, and 4% of that 20 is going to be 0.8. 0 times X, well, that's just gone, right? 0 times anything is 0. And what is it going to equal? Well, on the other side, we're going to have to distribute through. So watch distributing through. And we need 20 times 0.02, and that comes out to be 0.4 plus 0.02x. Is everyone okay with how I did that, right? Just draw your arrows. Now, be very, very careful with the decimals. Students make mistakes with the decimals. Notice I put the 0 in front, so it's 0.04. That way you don't make a mistake with that 0 in there. It's not 0.4. There's a 0 in front of it. So make sure you're very careful with the zeros. That's where students tend to make a mistake, is with the decimals. Now we need to solve it. So I'm going to take that 0.4 away from each side. Okay, subtracting those out. So that's 0.4 equals 0.02x. Right? And how do we finish it? Well, we need to get that x by itself. So we'll divide both sides by 0.02. And I'm going to put my x on the left-hand side. And we'll just divide those out. So 0.4. I'm going to divide that by 0.02. And that comes out to be 20. So what does that 20 represent? In this case, it is going to be in milliliters. So it's 20 milliliters of water. So I need to add 20 milliliters of water, and that is going to dilute it down to give me a 2% solution. The setup is where students struggle the most, at the very top. How I get to this. This is where students struggle, right here. Let's look at, how about 24? Now, 24 I'm not going to solve. We're just going to talk about how to set it up, because that's where we struggle. Solving the equation is not the problem. It's the setup. So 24 is going to be very, very similar to 23. Water must be added to 150 milliliters of a 10% essential oil solution to dilute it to 5%. How many milliliters of water should be used? So we do the same process. We've got our 3 boxes here. One, 2, and always on the right-hand side is 3. So this is what we're going to end up with. This is what we start with. We're going to add water. In this case, water is going to be added. So, what are we starting with? I've got essential oil, and I've got 150 milliliters of a 10% solution. So that's going here. I need to dilute this solution down, and I want to dilute it to 5%. So 5% is the end result, so that is going in box 3. Right, so I want to give the client 5% solution. You know, with essential oils, you have to dilute them down. Sometimes they're too strong. So I got to dilute it down with some water. Do I know how much water I have to add? No. But how much essential oil is in water? Again, 0%. These add together. The way I remember is 1 plus 2 is 3. So adding those together, that's 150 plus x. These add across. Now we can build our equation. So let's go ahead and build our equation, and that's going to be our pure. Pure is the amount times the rate. So let's try to calculate out our equation. I'm not going to solve it. Okay. The problem with it is not solving. The problem is always in the setup. So let's build our equation and move on to the next question, because I'm not going to solve it, because I don't think that's a good use of time. So when we make our equation, what do we have? We have 10%, so that's 0.1. How much is in there? 150. So those go together. Okay, that's box 1. What about the next one? 0%, so that's 0 times x. And what does it equal on the other side? Yep, 0.05, 5%. And how much is in there? 150 plus what? X. Okay, these go together, and those go together. Now, what about 0 times anything? That's gone. I'm not going to solve it, because solving it is not where students struggle. The problem is always the setup. So why waste a lot of time solving these right now? when we're focusing on the setup. 26 is a little bit different, but it's similar again. So question 26, what we're going to do is we're going to dilute this juice drink down. How many gallons of a fruit drink that is 50% real juice must be mixed with a fruit drink that is 20% juice to get 12 gallons of a fruit drink that is 40% real juice? Okay, so we're going to set it up the same way. It's a little bit different. But let's see what we've got. Always use the boxes 1, 2, and they equal 3. We've got an amount, and we've got a percentage rate. What am I going to start with? It says, how many gallons of a fruit drink that is 50% real juice? So that's what I'm going to start with, okay? We don't know how much is in there, but we know that it is 50%, right? It's the first piece we encounter. So we've got an unknown amount of 50% juice. We're going to mix that with a fruit drink that is 20% real juice. So we've got another container of 20% real juice. And what do we want to end up with? Let's make sure we're very careful here. It says we want to obtain, so that goes in box 3. We want to obtain 12 gallons. So that's going here, right? We want 12 gallons of a 40% juice. This one is a little bit different because what's going to go here? Well, we cannot just use the X again because we already used X in box 1. What goes here is going to be the total minus X. And how many gallons do I want to end up with? When I mix them together, I want 12 gallons, right? So if you don't know either one, and the first one is X, the second one is the total minus X. So what would that be? 12 minus X. It's always the total minus X every single time. Now we're going to build our equation. So let's try to get this equation. And what about the pure? Pure is the amount times the percentage rate. Okay, so we're not going to, again, solve these because students struggle more in the setup than they do solving it. So what would this look like as an equation for box 1? 50%, that's 0.5, unknown amount X. Box 2 or container 2, what's its percentage? 20%, so that's 0.2. And how much is in there? 12 minus X. On the right-hand side, that's box number 3. How much is in there? Okay, that's this one here. 12. What's its concentration? 40%. So that's going to be 0.4. It's 40% times the 12. Again, I'm not going to solve these because I don't think that's the best use of time. I think all of us can probably solve this from here. Okay, so let's try mixing. Instead of chemicals, we're going to be mixing money in different funds, different accounts. So let's look now at 28. So this one's going to be very similar. It's just that instead of working with mixing chemicals, we're investing money. So this is going to be the total amount over here. So it's going to be set up the same way. 1, 2, and it gives you a total. So let's look at question 28. Margaret won a prize for her work. She invested part of that money in a CD that paid 2%, and $3,000 more than that amount in a bond paying, 2% for the CD, 3% for the bond. Her annual interest income was $390. How much did Margaret invest at each rate? So we've got two different investments here. We have a CD, which is here, certificate of deposit, and we have bonds. So each of these has an amount and a percentage rate. So Margaret won a prize for her work. She invested part of the money in a CD that paid 2%. So what does that tell me? We've got a CD. Do we know how much is in there? No. Unknown amount, right? So unknown amount is in the CD. So we're going to use an X. What percentage rate does the CD pay out? It pays out 2%. Then we've got some bonds. We're going to buy some bonds. And what do we know about the bonds? It says $3,000 more than that amount. So $3,000 more than that amount would be X plus 3,000, right? Because 3,000 more, it's going to be X plus that 3,000. Now the bonds pay out a little bit more. And they pay out 3%. We can go ahead and get our total by adding across. And that's going to be 2x plus 3,000. Is everyone okay with how I did that? So we have some bonds. Unknown amount of money in the bonds. They pay 2%. CDs. So CDs pay the 2%, unknown amount. Bonds, there's $3,000 more in the bonds. They pay that 3%, so a little bit higher. The total over here, that's fine. We don't have a rate. And don't worry about that, because we now need to worry about the interest. And the interest is the amount times the rate. Again, it's just like the pure. Interest rate is like a tax rate. If I go to the store and I spend $100, tax rate's 10%. How much do I have to pay in taxes? $10, right? You took the amount times that percentage rate. Same thing with this CD. Okay, it's 2%. So if I put $100 in that CD, I would make out with $2 at the end, right? Because amount times the percentage. What we haven't worked with at all yet is that 390. We will deal with that in a moment. Bless you. So let's look at each one. The first one, what's in there? Unknown amount, percentage rate, 2%. So be careful with that. And that's going to be 0.02, right? It's not 0.2. Don't make that mistake. Make sure you have the correct number of zeros. So it's 0.02. We're going to then add that to the next one. And it's at 3%, so that's 0.03. How much is in there? X plus the 3,000. You know, this is where it's different. We are working with interest. So over here, this is going to be the total interest earned. And how much money did I make from these investments? $390. So that's why that's going over here, because that is your total interest earned. That's how much you got back from your investments. They're all a little bit different, but yet similar. Question 30. With income earned by selling the rights to her story, an actor invests some money at 3% and $30,000 more than twice this amount at 4%. Her total annual interest earned was $5,600. How much did she invest at each rate? Okay, so we've got to invest at different percentages. This is going to be our total, and I'll go ahead and label this as total amount over here. That way we don't get it mixed up with the interest. Total amount of money, and this is not the interest. Just so we don't get confused. A lot of times students mix up the interest with the total amount. Okay, so what are we going to start with here? We sold the rights to the story, and we put some of the money that we got at 3%. So do we know how much money we put in there? Unknown amount X. And what percentage does it pay out? 3%. So is everyone okay with how I picked out that piece? Right? That was the first part we encountered, and it said we invested some money at 3%, so that is unknown. So we use the X to represent that. All right? And it pays out 3% interest. Now we're going to invest some more money at a different rate. So now we go invest more money at a different rate. So we invest some of the money at 3%, which is what we did, and $30,000 more than twice this amount. So $30,000 more than twice this amount would be $30,000. Twice that amount would be 2x. All right, and what percentage rate does it pay out? Well, if we read here, it says it pays out 4%, so slightly higher. We're going to go ahead and add these across. And if I add these across, that's 2x plus that, 3x plus that 30,000. If I can say it correct. Right, so those are going to go together, and that's going to give us our 3x plus that 30,000. We have not dealt at all with the 5,600, because what is the 5,600? Interest. That is the last part that we look at. There's a big difference between interest and the amount in the account. Here's an example. If I put money in the bank, let's say I put $10,000 in the bank, and I get out $200 in interest, what's the amount? $10,000 in that account, right? That's how much money I have. Interest rate is going to be whatever percentage they give you, and then that $200 that I made, that is the interest. So the amount is always large, interest is always small. Think about it like putting money in a bank account, because that's what you're doing. So now let's look at our interest again. And interest is always the amount times the percentage rate. Okay. So what do we have first? 3%, unknown amount X. So 3%, that's 0.03, unknown amount X. Next one, 4%, so that's 0.04. How much is in there? 30,000 plus the 2x. And on the other side, what goes over there? Total interest. And how much total money did I make? 5,600. Okay, let's look at another one. Sure, And I can solve it if you need me to.
No, I don't. I get the solving part.
Right. Still, yep, and we're going to do more of these. Okay.
First line, y equals 3x. I see that.
Oh, this part.
No, there.
This one. Okay, so let's read
does
the...
that even matter when solving?
Okay, so let's talk about what the pieces are. So we're going to put some money. We made money off selling the rights to the story. Okay, so we go to the bank and they say there's two options. You've got a 3% that's guaranteed money and maybe a 4% that might be a little bit riskier. Now, we don't know how much we need to put in each fund, but I want to end up at the end of the day, at the end of the year, I want to make $5,600. So when I go in there, I'm going to put some money in the 3%. So do I know how much money I'm supposed to put in there? No. Unknown amount of money goes in here, so that's where the X came from. And what percentage rate does that pay out? 3%. Now, to make it work, I'm supposed to invest what in the 4%? It says to make it work, to invest in the 4%, I've got to invest $30,000, more than twice that amount. So that's the $30,000 plus the 2%. Or sorry, plus the 2x there. And that is then at 4%. Okay, you okay with that? I go ahead and have you add across, because otherwise if I don't, students will put the wrong thing. Somebody might put the 5,600 here, and it's not. Okay, that's the total amount, not interest. So that's why I have you add across, so that somehow it doesn't manage to get there. It's not. It's different. So now I have this. Now we're going to build our equation. Okay, and what do we work off of? The interest formula. And when we talk about interest, how does that work? Okay, interest is the amount times the percentage rate. So it's like taxes. So now we start building. Okay, those go together. And that gives me that piece, doesn't it? These go together, gives me that piece. And what is it supposed to equal? 5,600. Does that help answer that question a bit? So if it says unknown amount, you put an X there. Okay, so anytime it says unknown amount, an X goes there. Let's try one more, and then we'll take a short break. But yeah, I don't want to spend time solving these unless you really need me to, because I feel like that's not a good use of our time. It's more useful for us to set them up than to solve them. Let's look at another one of these, a little bit different. Question 32. Now, if they give you a table, we're not even going to look at the table, because I think the tables are a much more confusing way of handling these. I think the diagrams and the pictures make more sense for most students. So don't worry about the table. We're going to build our diagram. Question 32. And this is very, very similar to question 26. Carter invested a total of $9,000 in two accounts, one paying 1% interest and the other paying 4%. If he earned a total of $285, how much did he deposit in each account? So this one's a little bit different, but it's going to look like question 26. Okay, this is question 32. So let's talk about the setup here. Carter invested a total of $9,000. So what is that $9,000? That $9,000 in this case is going to go here. Why? Because that's how much total money I've got. Not the interest, right? Interest is completely separate. I've got a bank account and I've got $9,000. So that goes here, total amount. Is everyone okay with where that came from? Total amount of money here, $9,000. A little bit different from the last one. What am I going to do with this money? I'm going to break it up into two different accounts. one paying 4%, and one of them paying 1%. Doesn't matter which one we list first. That's irrelevant. Just put one of them at 1%, the other one at 4%. Okay, now, how much money am I going to put in the 1%? Do we know at all? Is that given at all? No. If we know nothing about it, we're going to put the X there, because that is completely unknown. Do I know how much goes at the 4%? No, that is unknown as well, isn't it? But if I don't know either one, I call one of them X. The other one, just like we did earlier on question 26, is the total minus X. So how much total money do I have? 9,000. So this one's going to be 9,000 minus X. Here's how you can look at it and think about it in a real life application. If I've got a container and that container has 8 gallons in it, and I take out 2 gallons, how many gallons do I have left? 6, right? How did you find that second, how much is left over? You took the total, which was 8 gallons, and how much did we take out? In this case, 2. Subtracted them, and what did you get? 6. Same thing here. Total was, in our case, the 8. We took out 2 gallons, that gave us the other one. Because 2 and 6 gives you what? 8. I know, it's just an analogy, hopefully it kind of makes sense with that. So one of them is X, the other one is the total minus X. And notice 1X is positive, 1X is negative. So what would happen with these if I were to add them together? They would cancel, and what would you be left with? 9,000 equals what? 9,000. See, the sides are the same. I'm going to go ahead and work this one out just so you see how I get both accounts. Because this one, we're going to get the 2 answers. I'm going to show you how to get both. Then we'll take a short break. So let's work with our interest. And that, again, is the amount times the percentage rate. And we'll label this one our first one. Okay, so unknown amount, X, percentage rate as a decimal, is 0.01. Next one is 4%, and that's 0.04. How much is in there? Minus X, okay? And what is it going to equal? Yep, total interest, not the amount. And my total interest is $285. Now we can finish it, right? So we're going to distribute through. I'm solving this one because we want to get both accounts. So we need to get both of them. So 0.01x plus, we've got our 9,000. And we're going to take 4% of that, which is 360, minus 0.04x, and that equals 285. We're going to combine our x's together, and that's a minus 0.03x, plus that 360 equals 285. Move that 360 over. The only reason I'm solving this one in particular is so you can get both of them. It wants both accounts. So I want to make sure you understand that you only get one of them. You have to get the other one as well. So we subtract them off, and that's minus 0.03x, and that's 285 minus that 360, which is a minus 75. We'll divide by that minus 0.03. And now we've got our x, which is 2,500. So what does that 2,500 represent? Let's make sure we know what that x really is. 2,500. That goes there, right? And what percentage rate went with that X? 1%. So we have $2,500 at 1%. Okay? We need to find the other one. What's the other one going to be? The other one is here. And what is it? Yep. Minus X, which in this case is 9,000, minus the 2,500. All right, and that comes out to be 7,500, isn't it? Oh, sorry, 6,500. Why did I make them stick to 6,500? And so we've got 6,500 at now 4%. How can we check our answer? Here's how you can check your answer. Let's see if it makes sense. We know they add up together to give you 9,000, right? How much money should we make? 285. Let's see if we get that. If we take 2,500 times that 1%, how much did I make on that one? $25. If I take the 6,500 and I take 4% of it, how much did it make? $260. If I add them together, what do I get? $285. So I know I did it correctly, right? You don't have to check them, but that's how you check them if you want to. And that makes sense because they add together to give me the 9,000, right, which is the total amount of money, and they multiply and add down to give me 285 in interest. So I know it works and it makes sense. Let's take a short break, and then we'll come back and we'll set up some more of these. Very, very important that we know how to do these. That's why we're spending so much time on them. So let's meet back here at about, let's say, 9:15. Okay, so meet back here about 9:15.